we have seen the Fourier series expansion of 2 pi periodic functions defined in the interval minus pi to pi, especially even functions and odd functions. In the case of even function, the Fourier series is the Fourier cosine series. A0 by 2, the fx is equal to A0 by 2 plus sigma n 1 to infinity a n cos nx. Similarly, if the function is a 2 pi periodic function defined in the interval minus pi to pi, if f of x is odd, then the corresponding Fourier series is the sine series, Fourier sine series, given by sigma n 1 to infinity bn sin nx. Second, today we are going to discuss how we can consider an example for an even function. Then find the Fourier series of f of x is equal to mod x. What do you mean by mod x? What is mod 3? Mod 3 is equal to 3, absolute value of 3. That minus plus mod of minus 3 is equal to 3. Absolute value of x mod x in the interval minus pi to pi. That means this function f of x is equal to mod x or absolute value of x defined in the interval minus pi to pi. And again f of x plus 2 pi is equal to f of x. If f of x plus t is equal to f of x, then fx is a periodic function with period t. Here f of x plus 2 pi is equal to f of x, that means fx is a periodic function with the period 2 pi. Okay? That means the given function is a 2 pi periodic function defined in the interval minus pi to pi. Then given answer given f of x is equal to mod x. What is f of minus x? Is equal to mod of x minus x, mod minus x. Absolute value of minus 3. Minus 3 is equal to plus 3. Minus 4 the modulus value is plus 4. Then minus mod x, mod of minus x is equal to mod x. X plus x. That is equal to f of x. Mod of minus x means mod of plus x. Mod minus 3 is equal to mod 3. Mod of minus 7 is equal to 7. Negative value and positive value consider that is function property. Mod x is the absolute value of x in the property. Then f of minus x is equal to f of x. If f of minus x is equal to f of x, that means plus x in the value, minus x in the value, and the same. The function is even. If f of minus x is equal to minus into f of x, then the function is odd. And f of x is an even. F of minus x is equal to f of x, that is fx is even. 2 pi periodic, f of x plus 2 pi is equal to f of x, 2 pi periodic function defined in the interval minus pi to pi. Okay? That means the even function is a 2 pi periodic function which is an even function defined in the interval minus pi to pi. Then the corresponding Fourier series is the Fourier cosine series. The cosine series is given by f of x is equal to a0 by 2 plus sigma n 1 to infinity a n cos nx, where a0 is equal to, what is a0? 2 by pi integral 0 to pi f of x dx. If the function is neither even nor odd, then what is a0? A0 is equal to 1 by pi into integral minus pi to pi f of x dx. 1 by pi integral minus pi to pi f of x dx. Since the given function is even, this a0 is equal to 2 by pi. 0 model pi double minus pi model pi 0 by 2 by pi integral 0 to pi f of x dx. That is a0 is equal to 2 divided by pi integral 0 to pi f of x mod x dx. This integral 0 to pi means x varies in the interval 0 to pi. That means there x is positive. If x is positive, what is mod x? X. That is 2 by pi into integral 0 to pi mod x means x dx. In the interval 0 to pi, fx is mod x means x is positive. And positive mod x is equal to x. That is 2 by pi integral of x square by 2 between the limits 0 to pi. That is 2 by pi, 2 outside divided by 2, upper limit pi square minus lower limit apply as 0. Then 2 cancelling with pi cancelling is equal to pi. That is a0 is equal to pi. That is 32. The Fourier cosine series is result 1 in which A0 is equal to pi. Then what is A? Similarly, A is equal to 2 by pi integral 0 to pi f of x into cos nx dx. Like 2 by pi integral 0 to pi f of x into cos nx dx. That is equal to 2 by pi integral 0 to pi fx. Fx is equal to mod x into cos nx dx. If x is positive, what is mod x? Is equal to x. That is 2 by pi integral 0 to pi mod x is x into cos nx dx. X into cos nx that's this is equal to 2 by pi. Now this product will apply first into the second. Like the first function. Then the second function. First into x into integral of cos nx. Integral of cos nx is sin nx by n. Cos into integral sin. Nx into derivative dividing between the limits 0 to pi. Minus integral of 0 to pi derivative of s. Derivative of x means derivative of x is equal to 1 into integral of second. Integral of cos nx is equal to sin nx by n into dx. First into integral of second minus integral of derivative of x1 into integral of second. That is equal to 2 by take that n outside. That is 2 by pi n. 2 divided by pi n. This is upper limit apply. Upper limit apply that x in upper limit apply that pi sin n pi sin n pi. If lower limit apply that 0 apply that x is equal to 0. The 0 will be total product of 0. The 0 minus integral sin. Integral sin nx is equal to minus cos nx by n between the limits 0 to pi. Sin nx into integral minus cos nx by n. That is 2 by pi n. This sin n by is equal to 0 n. This is 0. And 2 by pi n. Here n 2 by n pi into n. And here minus of minus and plus. Upper limit apply the cos n pi minus lower limit apply the cos n. Nothing. 2 by pi n here n. This minus into times 0. Minus into minus plus. Cos n pi minus cos 0. That is 2 divided by n square pi. What is cos n pi? Cos n pi is equal to minus 1 raised to n. Sin n pi is equal to 0. Minus cos 0 value. Sin n pi value 0. Cos n pi is equal to minus 1 raised to n. Cos 0 is equal to 1. This is n value. N is equal to 1 on the n 1 on what is this value? 2 divided by pi. This is minus 1 raised to 1. This is minus 2. This n 2 on even number on n even number minus 1 square is plus sign. Plus minus 1 is 0. n is equal to an even number a 0. n odd is minus 1 order minus 1 is minus. Minus 2 into 2 minus 4 divided by n square pi. If n is odd. If n is even, the value is 0. Okay. Then the back result. Then the back continuation. Then save it. Not like what the save it. Then the back continuation of the problem. We have what is A0? A0 is equal to result 1. That is pi in what is A? A is equal to 2 divided by n square pi. 2 divided by n square pi into cos n pi minus 1 raised to n minus 1. That is equal to 2 divided by n square pi minus 1 raised to n minus 1. If n is even, then minus 1 square, minus 1 raised to 4, minus 1 raised to 6, etc. Minus 1 square is equal to 1. Then 1 minus 1 is equal to 0. Similarly, if n is equal to 4, 2 divided by n square pi minus 1 square. Minus 1 raised to 4 plus 1 minus 1 0. Or if n is even, the value of n is equal to 0. Then is the A2 Fourier series expansion. In the Fourier series expansion, A2, A4, A6, A8, etc. are all zeros. Then next you assume that n is an odd number. If n is odd, for example, if n is equal to 1. If n is equal to 1, then this term is 2 divided by n square pi, 1 square pi, 2 by pi, minus 1 raised to 1. That is minus 1. Minus 1. Cos 0, that is minus 2. That is 2 by n square pi into minus 2. Similarly, next assume that n is 3, an odd number. Then 2 by n square pi, n is equal to 3 square pi, minus 1's cube, minus of minus 1. Minus 1 is equal to minus 2. And then if n is odd, minus 1 raised to n minus 1 is minus 2. If n is even, minus 1 raised to n minus 1 is equal to 0. Then A2, A4, A6, etc. are all zeros. A3, A1, A3, A5, that means odd powers exist. In that case, n is equal to minus 4 by n square pi. If n is odd. If n is even, the value is 0. And then an is 0. Then what is the Fourier cosine series of the given function fx is equal to mod x? Hence by 2 and 3. 2 and 3 means 2 value of a0. 3 means value of a. We have result 1. F of x is equal to a0 by 2 plus sigma n 1 to infinity a n cos nx. That is equal to fx is equal to a0 by 2. a0 is equal to pi by 2. Then a1, a3, a5, etc. master exist. What is a1? Minus 4 by pi. Minus 4 by pi into cos x. a1 cos x. Plus a3 minus 4 by pi. That is 3 square cos 3x by 3. 3 square. Minus 4 by pi. n into value 5 square. That is cos 5x by 5 square. Minus 4 by pi. Cos 7x by 7 square, etc. Okay, that is a minus 4 by pi and outside here. That is the Fourier cosine series of the given function f of x is equal to mod x. Fx is equal to mod x is equal to pi by 2 minus 4 by pi cos x plus cos 3x by 3 square plus cos 5x by 5 square plus cos 7x by 7 square plus etc. That is the function f of x is equal to mod x defined in the interval minus pi to pi. A periodic function. That is the Fourier cosine series expansion. Okay? This result is result x is equal to 0. If x is equal to 0, then f of 0. F of 0 means put x is equal to 0 in this result. Then f of 0 is equal to mod 0 equal to pi by 2 minus 4 by pi cos 0. Cos 3 into 0 means cos 0 by 3 square, cos 0 by 5 square plus etc. Okay. Then that is this is equal to mod 0 means 0. And in time 4 by pi cos 0 1 by 1 plus 1 by 3 square cos 0 divided 1 by 5 square plus 1 by 7 square is equal to pi by 2. This 4 by pi 1 square plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus etc. is equal to pi by 2 pi divided by 4 is equal to pi square divided by 8. Second, this is the Fourier series of the function f of x is equal to mod x. This is also an example for an even function. Even 2 pi periodic function defined the interval minus pi to pi. This is what we have done. We have already seen Fourier series of even 2 pi periodic functions or cosine series. Now consider an example for an odd 2 pi periodic function defined in the interval minus pi to pi. Perhaps find the Fourier series of f of x is equal to x in the interval minus pi to pi. Given f of x plus 2 pi is equal to f of x. That is, f of x is equal to x. The function is defined in the interval minus pi to pi. And moreover, f of x plus 2 pi, f of x plus t is equal to f of x. That is, the given function is a 2 pi periodic function defined in the interval minus pi to pi. The next check or examine whether the given function is even or odd. And for that, given f of x is equal to x. What is f of minus x? F of x is equal to x, f of a is equal to a, f of 2 is equal to 2, f of minus x is equal to minus x. That is equal to minus into f of x. And f of x is equal to x. Now minus into x, x means f of x. Or f of minus x is equal to minus into f of x. That is, the given function is odd. And or odd function, and moreover it is 2 pi periodic defined in the interval minus pi to pi. Or the given function f of x is equal to x is a 2 pi periodic function defined in the interval minus pi to pi, moreover it is odd. Then the Fourier series of the given function f of x is the Fourier sine series. And the Fourier sine series is given by f of x is equal to sigma n equal to 1 to infinity bn sine nx. So okay, what is bn? Bn is equal to, where bn is equal to 2 divided by pi integral 0 to pi f of x into sine nx dx. Second, that is 2 by pi integral 0 to pi f of x into sine nx dx. That is 2 by pi integral 0 to pi f of x. What is f of x? F of x is equal to x. The x into sine nx dx. That is, bn is equal to the first function in the second, first integral of second, and then that is equal to 2 by pi into first integral of sine nx. Integral of sine nx is equal to minus cos nx by n. First into integral of sine nx. Integral of sine nx is minus cos nx by n between the limits 0 to pi. Minus integral of derivative of x1 into integral of second. Sin nx dx. Sin nx in the integral minus cos nx by n into dx. Then take the denominator and take that n outside. That is equal to 2 divided by n pi. Then this is negative, this is also negative. Take negative also outside. That is minus 2 divided by n pi. Minus 2 divided by n pi. And upper limit apply. Upper limit apply, that is instead of x put a pi. That is pi cos n pi. Pi cos n pi. Minus x 0 and it will divide by x 0. First into integral of sin nx minus cos nx by n between the limits 0 to pi. Applying upper limit pi cos n pi minus 0. Then minus derivative of first 1 into integral of second. Sin nx into minus cos nx by n into dx. Then minus outside then minus cos nx into integral. Integral cos nx dx in the value sin nx by n between the limits 0 to pi. Second, that is bn is equal to minus 2 divided by n pi. Then pi into what is cos n pi? Cos n pi is equal to minus 1 raised to n. Minus 1 raised to n. It is 0. Here apply upper limit sin n pi. What is value sin n pi? Sin n pi 0. Lower limit apply that sin 0. That 0. Then that is equal to 2 minus 2 divided by n pi minus 1 raised to n. That is equal to, then if we assume that n is odd, n odd minus 1 raised to 1, minus 1 raised to 3, minus 1 raised to 5, etc. are all negative. And negative is multiply 2 divided by n. Pi cancelling. And then 2 divided by n if n is odd. The next you assume that n is even. And even minus 1 square, minus 1 raised to 4, etc. are all negative. Sorry, positive. Positive and multiply equal to minus 2 by n if n is even. And then if n is positive, then bn is equal. So if n is odd, bn is equal to 2 by n. If n is even, bn is equal to minus 2 by n. Okay? Then result to 1. The Fourier sine series of fx is equal to sigma n 1 to infinity, sigma n 1 to infinity, dn sin nx is equal to 2. Even what you can take 2 outside. 2 into n odd ആയാൽ 1 3 ആയാൽ എന്തായിരിക്കും 2/n. ഒരു sin b1 sin x അന്നേരം b1 ന്റെ വാല്യൂ എന്താണ് 2/1. അന്നേരം 2 into 2 ഔട്ട്സൈഡ് എടുത്താൽ sin x. What is b2? b2 is equal to n even ആയാൽ minus 2/n ആണ്. അന്നേരം minus sin 2x/2. 2/n minus 2 ഔട്ട്സൈഡ് എടുത്താൽ 1/n എന്നല്ലേ വരുന്നത്. ഇനി if n is 3, n 3 ആയാലോ b3 sin 3x. b3 is equal to 2/3. അന്നേരം 2 ഔട്ട്സൈഡ് എടുത്താൽ sin 3x/3. If n is 4 ആയാൽ b4 sin 4x. What is b4? b4 is equal to minus 2/4. minus 2 outside എടുത്താൽ n2 outside എടുത്താൽ minus sin 4x/4 plus etc. Or the Fourier series of the given function f of x is equal to x is 2 into sin x minus sin 2x/2 plus sin 3x/3 minus sin 4x/4. അതായത് b1 ന്റെ വാല്യൂ b1 sin x plus b2 sin 2x plus b3 sin 3x plus b4 sin 4x etc. അതിനകത്ത് n odd ആയാൽ അതെല്ലാം 2/n ആയിരിക്കും. n even ആയാൽ minus 2/n. That is the Fourier series of the function f of x is equal to x. Now this is an example for a Fourier series a function defined in the interval minus pi to pi. Moreover, it is odd and 2π periodic. And then if the given function is a 2π periodic odd function defined in the interval minus pi to pi, then the Fourier series expansion is the sine series expansion. Fourier sine series. There is no terms of cos x or cos nx. Only the terms of sin nx, sin x, sin 2x, sin 3x etc. Or in that case, the Fourier series is the Fourier sine series. എന്നാൽ ഇതുകൂടെ എന്ത് ചെയ്യണം, ഒരു ഓഡ് ഫംഗ്ഷൻ എക്സാമ്പിൾ ഇതുകൂടെ എന്ത് ചെയ്യുക, സേവ് ചെയ്യുക, നോട്ടിലേക്ക് പകർത്തുക. എന്നാൽ ഓൾ ഓഫ് യു സേവ് ഇറ്റ് ആൻഡ് റിറൈറ്റ് ദ നോട്ട്.